Hi everyone. Um, Welcome to your first screencast for remote learning. I know things are a little bit crazy right now in the world, but um, there, the College Board has been rolling out lots of addendums for the AP exam, and I'm going to make a separate post on that. And in the future, you might even get my face or Leo's face in the corner as we kind of work through these lessons from home. So we're just going to jump into it. And to go along with this, you'll have to answer study guide questions. I haven't quite figured all of that out yet. I'm doing this recording while I have a quiet house. So we're going into 8B nuclear, which is non-renewable because the source for nuclear energy is uranium or plutonium, which is a non-renewable resource that comes from the earth. So in the world, there are about 430 nuclear power plants. It supplies about 15% of the world's energy. In France, 77% of their electricity is nuclear. They do nuclear and they do it really well. In the US, it's about 20% of our electricity. There were a bunch of nuclear power plants slated to be built. And then after Fukushima, the nuclear disaster in Japan, everything um, was kind of put on hold. So the status of that still isn't great for nuclear power in the US. But if you look at this chart here, you can see that almost the entire world, except for a lot of the Middle East and eh, Italy and Greece and most of Africa, those places don't use nuclear, mostly because they have other energy sources, and some of those areas are very prone to earthquakes, which do not do well with nuclear power plants. um, the top 5 producers of uranium, as you can see on the bottom here. Ooh, Kazakhstan, Canada, Australia, Namibia, and Russia, not the US. And here's just another. This is just where nuclear power plants are the red, and then where they're planning on being built is that bigger bubble within it. And I don't know what the status is. This was from October of 2009, and that was before Fukushima. So in the US, this is where most of our nuclear power plants are located, and they're east of the Rocky Mountains. And on the East Coast, you have Indian Point, which I'm sure you've heard of, up in New York. There's Oyster Creek, which was the oldest operating nuclear power plants in the continental US. That's Forked River, New Jersey. You've got Hope Creek and Salem right next to each other in New Jersey. In Pennsylvania, you have got Susquehanna on the Susquehanna River, the Limerick, Peach Bottom, and also 3 Mile Island, which I'm sure you've heard about. If not, we're going to learn about as well. And if you look, there's one on Long Island, but I'm sure you've never heard of a nuclear power plant on Long Island before. Okay, so the Shoreham nuclear power plant, it was supposed to be a boiling water reactor, a nuclear reactor located adjacent to the Long Island Sound in New York on Long Island. And it was completed. It was built between 1973 and 1984 by the Long Island Lighting Company. But the thing is that after 1979, there was a nuclear reactor accident in Pennsylvania of 3 Mile Island, and then in 1986 you had Chernobyl, and there was a big protest, and a lot of groups opposed the plant, and it was ready to go, and it never opened. And the biggest thing also was because if there was an accident, a nuclear accident, they couldn't actually evacuate all of Long Island. And so the plant should have never been built in the first place. Okay. Uh, this is just, you can read through it. It was then decommissioned in 1994, which is absolutely crazy. So they spent all this money to build this nuclear power plant, and then they literally had to spend all this money to then decommission it, to take it apart. These are the nuclear power plants in New Jersey, and this one on the bottom is the very famous Oyster Creek nuclear power plant. And then you have um, either Hope Creek or Salem has 2 reactors. Has See, here's one reactor core and here's another reactor core. So there are 3 sites, but there are 4 actual reactors. This one here is the same one as here. And if you notice, they're all very close to water because just like in a regular power plant, you need water to cool the steam in a nuclear power plant. So Oyster Creek Nuclear Power Plant, a single unit, single reactor nuclear power plant in the Forked River section of Lacey Township in Ocean County. It was the oldest operating nuclear power plant in the U.S. It first started working December 1st, 1969, and it was licensed to operate until April 9th of 2029, but it closed early because it was just having so many issues, and it was only a matter of time before something happened. So they ended up closing the plant September 17th of 2018, and the plant uses cooling water from Barnegat Bay. So getting into what actually nuclear power is um, its radioactivity. But the way a nuclear power plant works is instead of using coal, oil, or natural gas to boil water, to create the steam, to turn the turbine, to turn the generator, what we're doing instead is we're using the heat from nuclear energy to boil the water, to create the steam, to turn the turbine. Okay? So still a non-renewable source. But if you're looking at an atom, you have the nucleus, which is made up of protons and neutrons. The protons are positive, the neutrons are neutral. Sorry if this is giving you flashbacks to chem. And then you have these electrons, which are negative. They orbit around the nucleus. And neutral atoms have the same number of protons and electrons. If the number of neutrons is greater than the number of protons, um, if the number of neutrons is greater than the number of protons, then you get an isotope. Alardi would be so proud. So a radioactive isotope is an unstable isotope, and it goes through radioactive decay, which is um, emitting these energetic particles or these rays, which is what actually creates the heat. So uranium decays over time to lead, but each isotope decays based on its own half-life. So like iodine has a half-life of 8.1 days, okay, 0.02 years. Whereas you look down to plutonium, 239 has a half-life of 24,400 years. Okay, so that's a lot of years. Krypton 85 is almost 10 and a half years. And so this isn't stuff that we take lightly here. So um, there's always a multiple choice question on how to figure out half-life on the AP exam. So I'm going to teach you guys how to do that now. All right, so strontium 90, it has a half-life of approximately 28 years. So initially at time T0, the sample is 100% of strontium 90. After 28 years, you have only the half amount. So a half of 100 is 50%. After another 28 years, you have only half. So instead of now having 50%, you have 25%. And then another 28 years, it goes 12.5, and so on and so forth. So in theory, you'll never decay down to zero. You just keep halving it and halving it and halving it. Okay, you remember asymptotes in whatever math that was? That's what this is. Okay, you'll never have to do complicated equations on this. So there's a video that I've linked here of how to calculate half-life. So after this, go through, watch that video, and it'll help you answer the questions that are for homework. Okay, you can set up a half-life graph as well. You can have the amount, the percent or the mass, and then you can have the half-life or the ratio, the amount of time on the bottom. So if you have a half-life of zinc 71, 2.4 minutes, if you have 100 grams at the beginning, how many grams are left after 7.2 minutes? Okay, so you go through, it's just half-life and half-life and half-life. So you have 100 grams, well, you have 2.4 minutes. 2.4 plus 2.4 plus 2.4 plus a half. Okay, that gives you your first half-life is a half. Your second half-life, you're going down to a quarter. Your third half-life, you're going down to an eighth. Okay, so you're starting at 100 grams, you're going down and down and down. Does that make sense? Okay. Your next example, if OS 182 has a half-life of 21.5 hours, how many grams of a 10-gram sample? So you don't have 100%, you have 10 grams, which is your 100%, would have decayed after 3 half-lives. Okay. So you have 10 grams, then you have 5 grams, then you have 2.5 grams, then you have 1.25 grams. Okay, so that's what ends up going down. So 8.75 grams have decayed. Okay, if you're confused, don't worry, that video is going to help you clear it up. Okay, so there are two different types of nuclear energy. There's fission, which is what we use, and then there's fusion, which is what we don't use. We haven't been able to figure this out. In one of the Spider-Mans, the it was an older Spider-Man. One of the guys was trying to do fusion, and it was the green guy with lots of arms. I'm sorry, I'm terrible at this. Um, Nuclear fusion is something we would have to heat up to an insane temperature. Okay, fusion is when you join two lightweight nuclei into a single heavier nucleus. This is a huge release of energy. The sun and other stars do this, but it uses up um, all of the elements, and so there's no radioactive waste. Okay, fission is what we use. We split an atomic nucleus into two smaller fragments, and that is accompanied by the release of a large amount of energy of heat. Okay, and that's what we use to boil the water to create the steam that turns the turbine. Okay, so you split a nucleus of a heavy element like uranium-235 or plutonium-239, and this creates a chain reaction. Okay, and it's a chain reaction that's very hard to stop, and we're going to get into that. And what this does, though, is it leaves radioactive waste behind. So it's still radioactive, but we can't then use it to boil water. So that's a big issue. Okay, so here's what happens here. With nuclear fission, we essentially take neutrons and we chuck them out of a uranium atom. So right here, you see this neutron? Oh, that was supposed to be an arrow. Huh. You throw that at uranium-235. Okay? Uranium-235, it splits then into a mother and a daughter, or two daughters. This is the mother and the two daughters. So it releases two different lighter nuclei and then three neutrons. These three neutrons now can hit other nuclei and then they split. So it's not exponential growth that happens, it's times 3. Okay, and every one that splits then creates 3 neutrons, which can split apart another atom. Okay, so fission, okay, like fission of planarias, is the splitting. Okay, a stable isotope is struck by a neutron. The isotope absorbs that neutrons, it becomes unstable, and it splits apart into 2. Okay, fission is not a natural event. Okay, this is something that only humans have done. Natural radioactive decay is natural. This is not a natural event. Okay, uranium-235 and plutonium-239 undergo this fission. Okay, and they can be used in nuclear reactors and in nuclear weapons. 1 kilogram of uranium, 2.2 pounds, fissioning that fissionable material releases more energy than burning 2 million kilograms of coal. So it's such a big bang for your buck in theory. Okay? So how it's used in nuclear reactors is only 0.7% of naturally occurring uranium is uranium-235, which does undergo nuclear fission. So before it can be used as nuclear fuel, it needs to be enriched to be 3% uranium. So when we were watching that documentary on power um, in the for your last lab, I guess it was, you guys saw the guy was holding rocks of uranium, and they were going around with a blue light, kind of lighting them up. So what we need to do is we need to enrich this fuel until we can actually use it. Okay, the enriched fuel is made into rods, which are then used in the nuclear reactor. Okay, so nuclear fission, oh, this isn't going to work, is used to generate heat in a reactor, and it involves splitting these nuclei into smaller things. And when I figure out how to do this, I'll get this to push play and you'll actually see it happening. Okay, but we're not going to have that now. Sorry. Okay, so your products of fission, it splits into two smaller nuclei known as these daughters. So here is your neutron. It hits the mother. It splits into one daughter. Why isn't this working? There we go. One daughter, two daughters, and then you get one, two, three neutrons, which then go on to split others. Okay? I'm sorry. I feel like this was kind of long-winded, but now you're going to answer some study guide questions and turn those in. Well, it won't be turned in. It'll be on on a Quizlet kind of thing or a spreadsheet kind of handed in thing. So I'm gonna figure that out. All right. Stay safe, everyone.